Assalamualaikum warahmatullahi wabarakatuh. My name is Arif Mustain bin Muhammad Ilyasawi, and I will be presenting to you in this video about how me and the rest of the group 7 members uh, complete the assignment that in the course program DAE 21303 Electronics. Before we get further into this video, I would like to introduce the rest of the members of Group 7. The first one is Nur Syazwani binti Rambeli. Her number matrix is AA211390. The second one is Muhammad Ahmad Haziq bin Muhammad Razi. Number matric AA210589. And the last member is myself, which is Arif Musta'in bin Muhammad Ilyasawi. Number matric AA211306. I will be focusing about the introduction of our assignment. A bias circuit is a portion of the device circuit which supplies currents, which is amperes, or voltage, which is volt, to the circuit. In this assignment, it is required to build several transistor bias circuits that will be supplying the transistor with amperes or volts. The types of transistor bias circuit that we built during this assignment is common emitter amplifier with emitter stabilized bias, and common emitter amplifier with voltage divider bias. We will also include the calculation and the simulation in this assignment. For the next slide, I would like to give it to the other members, which is Muhammad Amazi. Thank you.
So, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad bin Muhammad Razi. My matrix number is AA210589. So I'm going to present about acid saturation from the data sheet. So this is the data sheet of transistor 2N 42s, and the acid saturation is at VCE max, which is 0.4 volt, and the IC saturation is 150 milliamp. So from the data sheet, we can get the VCE max and also the IC saturation. As for the design stages, there are two parts, which is part 1 and part 2. So in part 1, the VCC is 27 volt and beta is 115. IC saturation and VCE max we got from the data sheet. So as for number 3, for part 1 is we calculate ICQ by using 1/2 IC saturation, and for ICQ we get 75 milliamp. VCE is VC is 0.5 VCC. So the total of VC is 13.54 volt, and VCE is 0.15 VCC, and VE the total of VE is 4.05 volt. From both of these voltage, we can search for RE for question 6, and RE is 54 ohm. Sorry. After that, for question 7 is to calculate the RC using the formula RC equals to VCC divided by IC saturation minus VE. So from the equation, the answer that we get is 26 ohm. As for question number 8 is to calculate the IB. IB we can get from IC divide by beta, and the answer that we get is 682.17 microamp. And for the last question is to calculate RB. For by using the formula of VCC minus VBE divided by IB and minus beta plus 1 RE. So from those formula, we get RB is equals to 3.41 kilo ohm. As for part 2 of design stage, for question number 1 until number 7, until number 6, it's actually the exact same calculation as part 1. So as for number 7, we're going to search for RC, but the equation for RC for part 2 is VCC minus VCE minus VE divided by IC. So in part 2, our RC is 300.7 ohm. For question number 8 is to search the total amount of R2. So by using the formula of 0.1 multiplied by beta and also multiplied by RE, we get that R2 is 621 ohm. And for question number 9 is to calculate the VB from the formula VBE plus VE, and we get 4.75 volt. Number 10 question is to calculate the R1 from the equation given, and the answer for R1 is 2.9 kilo ohm. As for question 11, we need to confirm that the calculation from the question 10 is the exact same total of R1s, which is in question 10 we get R1 is 2.9 kilo ohm, and in question 11 we also get R1 the total of 2.9 kilo ohm. As question 12, we need to calculate the remaining variable, which is IB, IE, IR1 and IR2. For IB, we get 682.17 microamp, IE 75.7 milliamp, IR1 is 9.3 milliamp, IR2 is 8.65 milliamp. So that's all for me for the presentation. Thank you very much.
Assalamualaikum dan salam sejahtera. My name is Nur Syazwani binti Ramli, number metri AA211390. For this, I want to present simulation result. For part 1 is design a common emitter amplifier with emitter stabilized bias. For this part, we use 27 volt and we use 2N200 2022 for this transistor. Okay, we get current of collector is this, and voltage of collector 10.4 volt, and uh, current of base is this, and voltage base is we get 21.7 volt, and this for current of emitter, and voltage emitter we get 4.5 volt. And for part 2 is design a common emitter amplifier with emitter stabilized bias. Okay, for this part we use 27 volt and the same transistor, and we get voltage of collector is 20.1 volt, and this for current of collector, this for current base, and this for current emitter, and this voltage we get is resistor on this part. Okay, next we continue the presentation or the conclusion. The reason why various transistor bias circuit was built is to establish a no quiescent operating point or Q point for the bipolar transistor to work efficiently and produce an distort output signal. Okay, for the common emitter amplifier with emitter stabilized bias, we get a few advantage, such as emitter resistance reduce much of the circuit gain variability, and disadvantage for this, it reduce the output gain due to the base resistor connection. Second is common emitter amplifier with voltage divider bias. For advantage, the resistor have to give complete control over the voltage and current that is received in the resistor. Disadvantage is the signal tend to get mixed up at time. So that's all from me and my team. So thank you.